Hey everyone, and welcome. So, you've tried to run an Azure load test against a private endpoint, and boom, you get hit with some bizarre error. It's super frustrating, I know, but today we're going to fix that. We are going to walk through a step-by-step guide to get those tests running perfectly.
I mean, picture this, right? You've got your app all set up, it's nice and secure behind a private endpoint, and now it's time for the fun part, seeing what it can handle. You kick off the load test, you're waiting for those awesome metrics, and nope, failure. You're just staring at some error code like ALTVNET 015, thinking, what does that even mean? If that sounds familiar, don't worry. You're definitely not alone, and the fix is usually way easier than you think. So, to really solve these problems for good, we first have to understand what's actually happening behind the scenes. See, when you tell Azure Load Testing to hit a private endpoint, it can't just throw traffic at it from the public internet. That would defeat the whole purpose of it being private. It needs to get inside your network to do its job. And that whole process, that's the key to figuring out pretty much every single issue you might run into. And that process has a name. It's called VNet injection. The easiest way to think about it is like this. Azure has to parachute its load-generating machines right into your private virtual network, your VNet, so they can sit right next to your application. Now, this is all temporary, of course. But for it to work, it needs the right permissions, and the network has to be set up correctly. And here's the kicker. Most of the time, it's not your test script that's failing. It's this injection process that's hitting a wall. And it's pretty interesting to see what Azure is actually deploying. It's not just one little thing. It's the whole shebang. You've got the VMs that act as the test engines, a public IP address and network security group, and even an Azure load balancer. When you see this list, it suddenly makes perfect sense why so many different things, from permissions to IP quotas, have to be lined up perfectly just for the test to even begin. Okay, before you even bother looking at an error code, I'm going to give you the single most powerful diagnostic step you can take. Seriously. I call it the connectivity first check. Why? Because a lot of the time, this one check will solve the problem before you even know what the specific problem is. It's all about making sure the subnet you're trying to use can actually talk to the services Azure needs it to. And the best part is, this process is super simple. All you do is spin up a quick, temporary virtual machine, nothing fancy, inside the exact same subnet you told the load test to use. Then you just hop into that VM and run two little commands, nslookup to make sure you can find things, and curl to make sure you can actually connect. It's a foolproof way to see exactly what your subnet can and, more importantly, can't reach. So what are you actually looking for? Well, those test engines need to phone home. They have to communicate with a few critical Azure destinations to get their instructions and report back. We're talking about core services for Azure Batch, storage, and the container registry. If your curl command to any of these fails, bam, you've found your problem. It's almost certainly a firewall or an NSG rule that's blocking that outbound traffic. All right, so what if you do that connectivity check and everything is green? Everything looks great, but your test still fails. Okay, now it's time to look at those error codes. And the good news is, they aren't nearly as scary as they look. Each one points to a very specific issue with a very specific fix. It's like a roadmap from problem to solution. Let's start with a total classic, ALTVNET 004. This is a permissions issue, plain and simple. It just means the service doesn't have the right to join the subnet. Remember that VNet injection we talked about? This is the error you get when the bouncer at the club looks at your test and says, sorry, you're not on the list. The fix couldn't be easier. Just grant the network contributor role on the VNet, and you're in. Next up, ALTVNET 003. This is a configuration conflict. In Azure, a subnet can be delegated, which is like reserving it for a specific service, say Azure SQL. And the thing is, you can't reserve it for two different things at once. It's like a reserved parking spot. If you get this error, you've got two choices. Either remove the delegation or, probably easier, just pick a different subnet that isn't already reserved. Sometimes the problem isn't your configuration at all. You can have the permissions perfect, the subnet wide open, and still fail. That's because you might be hitting physical or subscription level limits. These errors are all about just plain running out of stuff, and they're just as important to check. ALTVNET 014 is a perfect example. It's just simple math. Every single test engine needs its own private IP address. So if your test is going to spin up, say, 10 engines, but your subnet only has 5 free IPs, well, it's not going to work. The fix is exactly what you'd expect. Just expand the subnet's address range to give it more room to breathe. Oh man, this one. ALTVNET 015. This one catches so many people off guard.
Management locks are awesome, right? They protect your important resources from being accidentally deleted. But that same lock also prevents Azure Load Testing from deploying its temporary resources into that resource group. The service is trying to create VMs, and the lock is just standing there going, nope, not on my watch. The solution is simple. Just temporarily remove the lock, run your test, and you can put it right back on when you're done. And finally, we have ALTVNET 016. This error is a great reminder to zoom out a little bit, to look past the VNet and at the subscription itself. Remember how a public IP is one of those things Azure injects? Well, your subscription has a hard limit, a quota on how many public IPs you can have. If you're already at your max, the deployment is going to fail. You'll need to either delete one you're not using or just request a quick quota increase.
Okay, we have covered a ton of ground, from the big concepts down to the nitty-gritty error codes. So let's pull it all together into a simple, repeatable playbook that you can use every single time you hit one of these roadblocks. Think of it like a funnel, where we start broad and get more and more specific.
And here it is, your 4-step diagnostic funnel. 1. Always start by checking outbound connectivity. 2. If that's good, check your permissions. Do you have that network contributor role? 3. Inspect the subnet itself. Is it free? Meaning, is it not delegated or stuck in some failed state? And finally, step 4, verify your resources. Do you have enough IPs? Is your subscription quota okay? And are there any pesky management locks in the way? If you follow these 4 steps in this order, I promise you, you will solve 99% of your private endpoint testing problems. So the big takeaway here is that these failures are not a black box. They're not some random, mysterious thing. Once you understand VNet injection and you have this clear diagnostic funnel, you have all the power you need to figure out exactly what's wrong and fix it fast. Those cryptic errors, they're decoded. You are in control now. So the only question left is, what are you going to go test next?